Hi, Astronomy. This is Mr. Janowski. This is I don't know if it's the third or the fourth, whatever. It's the next part of the Chapter 1 slides. So let's keep this quick. So, what is the shape of the Earth's orbit around the Sun? The Earth orbits the Sun in an ellipse, this particular kind of oval. And the GIF is showing you how to mathematically or geometrically construct an ellipse, which you're not going to have to do for me. So, when is the Earth closest to the Sun? Actually, in northern winter, on January 3rd, the Earth is the closest to the Sun. So, it's not the nearness or farness of the Earth to the Sun that causes the seasons. It's something else. So, question 3, what causes the seasons? Yeah, it's the tilt of the Earth's axis. That's where we get the seasons. So, the distance the Earth is from the Sun has an effect, but it's a fairly small effect and much smaller than the effect that the tilt has. So here we're talking about solstices, equinoxes, and the ecliptic's tilt. So the fact that the Earth's axis is tilted relative to the plane of its orbit is what gives us the seasons and what leads to the solstices or sunstops and the equinoxes, which means equal nights. So if you look at, just let's look at this top picture right here. So this is the plane of the Earth's orbit. So think of a geometrical plane extending out in all directions. And the axis of the Earth's rotation is not perpendicular to that plane. We think that billions of years ago it was when the Earth was still forming, but then the Earth went and got itself knocked into by some giant mess of something that eventually led to the development of the moon. So that's still hypothetical. It's a hypothesis. We're not sure of that, but that's what we think it is. So anyhow, yeah, the fact that the Earth's axis is tilted is why the ecliptic is not the exact same thing as the celestial equator. There's an angle between them, and this gives rise to the seasons and the solstices and the equinoxes. So for 3 months prior to June 21st, the sun appears to rise higher and higher above the celestial equator. So for those 3 months, we would have started here. For the next 3 months, the Earth is doing this part of its orbit, and the sun rises higher and higher above the celestial equator. So the days will be getting longer for those 3 months, and actually for the 3 months before that, in fact, until eventually the sun gets to its highest point above the celestial equator, and at that point, it stops. So we call this a solstice, a sunstop. And that happens on June 21st, the first day of summer. And then for the next 3 months, so from where the Earth is in this first picture to where it is in the second picture, it's going around. And now the sun is falling closer and closer to the celestial equator. And the day that it actually gets to the celestial equator is the equinox, in this case, the fall equinox. So the Earth is here in its orbit. And at this point, every single location on Earth has 12 hours of daylight and 12 hours of darkness. And then for the next 3 months, the sun keeps falling lower and lower. So on September 22nd, the sun was on the celestial equator. For the next 3 months, every day it gets a little bit lower beneath the celestial equator. Until finally, one day it stops, and it stops getting lower, and that is the winter solstice. That is the winter sunstop. That is the shortest day of the year, and that's the start of winter, if you're in the northern hemisphere, which we are. And then to complete the cycle, for the next 3 months, it goes from here around to here, and the sun starts rising again higher and higher from its lowest point beneath the equator until on this date, March 20th, the first day of spring, the vernal equinox, the sun is back on the celestial equator. So yeah, these pictures here, and hopefully you can make those ideas line up to this picture here. So how do these pictures relate? So this set of 4 pictures on the left is what's actually happening. This picture here on the right, well, this is the celestial sphere. And again, remember, this is a model. So this is what's happening. The Earth is going around the sun. According to the celestial sphere model, you think of it, even though we know this is wrong, it's still very useful. You think of the Earth being at the center, and it looks like the sun is traveling across the celestial sphere. It's traveling across the ecliptic on the celestial sphere. We started, okay. So this top picture would actually be when the sun is here. It's at its highest point above the celestial equator. The next 3 months, gets us to here. It's on the celestial equator again. So that's the second picture. The third picture, so again, notice in the third picture, the sun is actually, let me call it to the left of the Earth here. But what does it look like from the Earth's position? From the Earth's position, it looks like this. Okay, so that's how these work. I'm trying to explain this quickly so the video doesn't get too long. If I'm going too quickly, just go to Google Classroom, look at the slides, and read through the slides more slowly. So tracking the sun's changing position. So because the sun travels north and south of the celestial equator, it follows different paths across the sky each day. So we started our story kind of on June 21st, the summer solstice. So this is where the sun is most north in the sky. So this is the sun at sunset. But what happens on this day is the sun rises not due east, it rises its most north of east. So it rises in the northeast. So on June 21st, the sun would be here, and it makes this very long path across the sky. So the sun is up very long that day. That is the longest day of sunlight of the year. And notice where we live at a mid-northern latitude, at no point during the year is the sun ever directly overhead. That just doesn't happen from Pennsylvania. So on the longest day of the year, it's as close as it's going to get to the zenith, the point directly overhead, but it's never directly overhead. And then for the next 6 months, it's going to be lower and lower, but let's just go forward 3 months. So 3 months later, we'll be at the winter solstice. So on the winter solstice, the sun will, I'm sorry, these pictures again, I did this in class too. So the pictures are not in chronological order. I don't know why I did it this way. This is how the textbook must have done it. So 6 months after the summer solstice, we get to the winter solstice. So we would have passed through the fall equinox, and now here we are on the winter solstice. So on this day, the sun starts in the southwest. I'm sorry, it starts in the southeast, goes across the sky. Notice it doesn't even get very high in the sky at all during this day. And notice how much shorter this path here is compared to this path here. So, yeah, the sun doesn't spend as much time in the sky on the winter solstice, the shortest day of the year, as it does, especially compared to the summer solstice, the longest day of the year. And it's the 2 days on the equinox. Those are the days where the sun is going to rise due east from everywhere on Earth. It's going to go across the sky. And in Pennsylvania, again, it's not going to get directly overhead. It goes kind of medium high in the sky that day. And then it sets due west. So where you are on the Earth relative to the equator and the poles, so how far north or south you are of those things, has a huge effect of what the sun is going to do. So we start at the North Pole. The North Pole is far and away the craziest one. So if you're very near the North Pole, if you're within the Arctic Circle, you're going to have a couple days of year maybe where the sun doesn't actually rise or set. It stays up all day, does a loop, or some days it never actually rises. But if you're actually on the North Pole, it is the most extreme and the weirdest it could be. Because if you're actually on the actual North Pole, you have 1 6-month period of daylight followed by 1 6-month period of darkness. It's really kind of nuts if you think about it. So if we started on March 20th, so the spring equinox, the sun would be exactly on the horizon that day. And what does the sun do that day? It never really rises. All it does is do a loop all the way around on the horizon, and it goes up just a little tiny bit. It just gradually gets a little bit higher as it's going around. And the next day it goes around again, and it gets a little bit higher. And at no point does it set. And for the next 3 months, it just goes higher and higher in the sky until on June 21st, it does a loop around the sky. This is the highest the sun will get in the sky on the summer solstice. And then the next day, it'll do another loop, but this one's going to be a little bit lower. So the sun is going to keep falling and falling over the next 3 and 6 months. So 3 months after June 21st, the sun is back on the horizon, and that day it's going to make a loop around the whole thing, and it'll be a little bit below the horizon at the end of that 24-hour period. And for the next 6 months, you don't see the sun again. For the next 3 months, it goes lower and lower beneath the horizon until you get to the winter solstice, and then it takes another 3 months for it to get a little bit higher and higher every day until it's back on the horizon again. So yeah, daylight and darkness at the actual North or South Pole is crazy. So the equator is not as crazy and severe, but a couple of cool things happen on the equator. So if we're here on the equator, the sun is at its southernmost in the sky on December 21st, but it's still not very southern. It's just a little bit southern. And what does it do that day? It rises, goes up, comes down. And it's not overhead, but it's nearly overhead. And then 3 months later, the sun would rise due east and would make this arc across the sky. And if you're on the equator at noon that day, the sun would literally be directly overhead on the equinoxes. And then it sets due west. And then 3 months later, you get to the winter solstice. I'm sorry, I did the pictures backwards. No, I'm sorry. 3 months later, you get to the summer solstice. And now the sun is at its northernmost journey across the sky. And then another 3 months later, it's here. And then 3 months later, it's here. And it just keeps doing that. So yeah, if you're on the equator, on the equinoxes, the sun is directly overhead. So that happens twice a year. If you're on one of the two special lines of latitude around the Earth, the northern one is called the Tropic of Cancer, and the southern one is called the Tropic of Capricorn. On the solstices, on one of the solstices at each of those locations, the sun will be directly overhead. So here we're looking at the Tropic of Capricorn. I wish the book had given us the Tropic of Cancer instead to do this with. But Tropic of Capricorn. So we're going to start on December 21st. So the sun is at its southernmost point on December 21st, so it's not due east. It rises at noon. It's directly overhead. It's on the zenith, and then it sets over here. And then 3 months later, you're going to get to one of the equinoxes. And everywhere on Earth, on the equinoxes, the sun rises due east, goes across the sky, not overhead from this location, not directly overhead, and sets exactly due west. And then 3 months later, you get to June 21st. So if you're on the Tropic of Capricorn in the southern hemisphere, June 21st is your shortest day of the year in terms of sunlight hours. So, hint. If I showed you these pictures, when might I show you these pictures? I might show you these pictures on the test you're going to take next week. So be able to see these pictures and recognize what's going on and identify, just match each one to, is this picture showing me something that happens at the equator? Is it something that happens at the tropics, one of the poles, or one of the middle latitudes? So if you want to figure it out for yourself, pause the video right now. Otherwise, I will tell you the answers in 3, 2, 1. There they are, B, D, A, C. So this one is the equator. D is one of the tropics. It's the Tropic of Capricorn. This is the southern tropic, the one below the equator. Below, more south of the equator. One of the poles. Yeah, the poles are the weird ones. These are pretty easy to identify. And then the last one is a middle latitude. So this happens to be a mid-northern latitude. And then we watch this video from 60 Symbols where the nice Dr. Megan Gray and Dr. Mike Merrifield? I think it's Merrifield. They tell us about what the sun does at different points in the year, what a solstice actually is, what the equinoxes actually are, and all that goodness. So what is the path the sun traces across the celestial sphere? This is the ecliptic. So the ecliptic means two things, and they're really the same thing. There's just two different ways of thinking about it. You can think of it as the path of the sun across the celestial sphere. So that's if you're doing the celestial sphere model. The other way of thinking of it is the ecliptic is the plane of the Earth's orbit. And they end up being exactly the same thing. 2, when is the Earth closest to the sun? In the middle of northern winter. Towards the beginning of northern winter, I guess. So it's actually in January. So again, it's not the distance from the Earth to the sun that causes the seasons. What causes the seasons? It's the tilt of the Earth's axis relative to its orbital plane. So the Earth's axis in these pictures, you can tell the Earth is tilted. And if you've ever looked at a globe, Every globe you'll ever see comes with a tilt, and that is not poor quality control at the globe factory. They're all tilted for a reason. It's because the Earth's axis is tilted relative to its orbital plane. So that's it for this part of the slides, and hopefully you guys found that helpful.